Hello everybody and welcome to this new video. Today we'll be building some extensions to the number display units we built last week. They're right behind me. Although this thing is fully functional, there are still some things we can add to it to improve it. So let's get started. First, last week I told you that that number display unit in my complicated computer. Go check that video out because otherwise you won't understand a thing of what I'm saying today. That it takes an input in bits to turn it into a decimal number. But now you need to manually flick the levers from 0 to 9. That's not really binary. So let's change that. First we need to figure out how many bits we will need to represent these 10 different numbers. Well, if you remember, the formula of calculating how many different numbers you can get from a certain amount of bits is 2 raised to the power of the amount of bits you have. So for example, if you have 1 bit, 2 to the power of 1 is 2. You can represent either 0 or 1. With 2 bits, 2 to the power of 2 is 4, from 0 to 3. With 3 bits, you can represent 8 numbers, and with 4 bits, 16. Now here we have 10 different numbers, so we'll need to use 4 bits. Of course, a portion of those numbers we will not be able to represent yet, so they'll just go into a line that doesn't lead anywhere. How do we make that work? We'll make use of a multiplexer. What is a multiplexer? Well, as you might have guessed, it takes an input from bits and activates the according line with it. For example, to explain it, if you turn in 0, 0, 0, 1, then that is line number 1, and it will activate this line, which is number 1. For if you do, I don't know, 0, 1, 0, 0, that is 4, so then it will, or wait, is it? Yeah, it is. Then it will activate line number 4. I mean, it is number 5, but 4 in decimal. And so I laid all the different combinations out. Black is 0, white is 1, so 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and so on. Of course, we don't go to 1, 1, 1, 1, because we only have 10 bits, and 1, 1, 1, 1 is actually so would be the 15th number. Now we have to make this thing working with redstone. And I already explained this one time in the registers episode, but I'll explain it again. So how do we do this? Well, instead of activating the lines that needs to be activated, we activate all the lines that don't need to be activated, and then we invert it. Now, because we already need to invert it over here, we'll actually just get rid of this redstone torch and just make a redstone line, because 2 redstone torches will just result in the same output, and then it's just causing delay for no good reason. How do we activate all lines that don't need to be activated? Well, before all the black ones, we put a repeater down like this, and for all the white ones, we put a torch. Let's hope it doesn't mess too much with the system. So what will it do? For example, now this line isn't powered. So this repeater isn't powered and it doesn't power this line. What this says is that with this line being 0, it is possible that it is this line. Maybe, not for certain. Of course, then also this line needs to be 0 and this line and that line needs to be 1. But, for example, because this line, of course, it's not fully extended, but let me fix that. Because this line isn't powered, this redstone torch is powered, and that powers this line, and that means it can't be this line anymore. Because if it would be this line, it would this would have to be a 1, and it isn't, so it can't be. So we do that for all of them, and then it's basically done. Quite simple, actually. A little bit, maybe the system is a little bit complicated to understand at first, but it's once you understand it, it's not that hard. I'll build it immediately. So it's done, the multiplexer is done, and it works accordingly. For example, now it's set to 0, 0, 0, 0, so you would be expecting 0 to appear here, and it does. Let's try, I don't know, 5, 5, and we see 5. Next, let's do something that is impossible, so let's just do 15, and now nothing is appearing because none of these lines match, so it stays flat. That is our first extension, but let's address the big elephant in the room, making this a double number display, unit, so with two numbers, so you can show bigger numbers from 0 all the way to 99. So I'm all done with connecting the lines. As you see, I've done this one in gold to distinguish him more easily from the other one. It's a lot messier than the other in lines, as you see. That's why it's recommendable for if you have more than 2, for example 3, 4, 5, to create some kind of system, because otherwise it just gets unbearable messy. Now it's set to 0, 0 for the moment. That one's also set to 0, so we have 0, 0. Let's try, I don't know, 2. That's 2. And we have 2. Now we have 20. I won't go up that much. I'll just stick to this for this. If you want to expand it, it's just adding some more lines. The system stays the same. Okay. But of course that's not the real difficulty about getting to two numbers. So let's get to the real thing. To build a component that will be needing to add this additional number, I'll first move this out of the way. Okay, so that we have a little bit more room to work with, and I'll be extending these lines. So it's always not a bad idea to extend lines. You can't do really harm. It gives you some space to power the lines. So let me just do that real quick. So I'm all done with extending the lines. Here are the upper lines and here are the bottom lines. I already installed the repeaters, and as you see, I also made some lines on top of those, which run horizontally instead of vertically if you look at it this way. And those are 16 lines. 16 lines, as you might have remembered, that is the same as 2 to the power of 4. So those are going to be all our input lines. So the idea is that this component is going to sit here, and it will run the output into these lines, and for that we need to split the lines up. So for example, if this is one of the outputs from that component, we take that output, and with the repeater you split that signal up like this, and then if you power this, it will power this line and this line. Oh, I forgot to replace the repeater over here. Yep, okay, fixed. So let's do that for the entire row. And again, slash stack for 15. Oh, I didn't really do it to the entire top. So let's do that again. Oh, and second position is it right now? I don't know. Let's reset first position to be sure, and let's redo. Damn it. Okay, I didn't place the levers, but that's not really a problem because they are not here to stay anyways. So now it's just a matter of making this thing bigger and setting it to this side. And also, one other thing, of course these lines go on top of it, but they don't really do anything. How we will fix that is with redstone torches again. So what the idea is these lines are going to be powered, so by default, but when they get unpowered, the redstone torch will go on powering this line. And each line, for example, these are the lines for the left one, so those are numbers like 10 or 20. So for example, this is 0 0. So what needs that number to be? If the number it needs to represent is 0, well, 0, and then we'll power the line 0. Same over here, needs to be 0. Then 1 needs to be 0, 1. So again 0, but this time this needs to be a 1. So this one is for the right number, and that one is for the left number. And so you need to go through this entirely. This one is going to be a lot of zeros and a few ones at the end, and this one is going to go from here all the way to that side and then start over again over here when this jumps to 1 and end up about here or so with 6. So I'll place all these repeaters first. I mean redstone torches. And I'm done. I also did this with rotated. I had a little bit of trouble, but I think it all works. So for the moment, this is set to 0, 0, 0, 0. I'll place some redstone lamps so it's more clear which lever is powered and which isn't. So 0, 0, 0, 0, and that should be 0, and we have 0, 0. Let's do, I don't know, 10. What is 10? I think this is 10. 8 and 2, that makes 10, and we have 10. Let's do something else. 8. 8 is just, or let's do 7. And 0, 7. It works. So this is the end of this little mini-series. There isn't really any way you can, I mean, I'm pretty sure there is. You can, of course, if you want to have more numbers, it's just a matter of extending this line and extending this. Oh yeah, also one thing, here you have to place redstone torches again. Why? Well, the reason you didn't have to was because this was already inverted. But this doesn't invert it, and this needs to get an input inverted. Okay, it's a little bit complicated, But what basically happens is this gives the output inverted. So everything is powered except this one, and this is the right line. But because this also works with redstone torches, it will only power the line that is unpowered. So it will only power the redstone torch from which the line is unpowered. So here, again, it will only power one line. But here, all the lines need to be powered except for the line that needs to be powered. So this one. And so it needs to be inverted again. And uh, here the lines all need to get powered. No, all lines that need, yeah, it's just all lines that need to be extended get powered. That's quite easy. I already explained it in the previous episode. So that's it. Thank you for watching. If you liked it, if you learned something from it, please consider subscribing and liking. It would really, really, really make my day. I hope you have a good day, and bye!